Okay, good day for the last topic under the right spherical triangle. Okay, so we do have the topic about the isosceles spherical triangle. And what is an isosceles spherical triangle? So it looks like this. So to describe it, it is a spherical triangle with at least two equal sides. So if you can remember, so when we say right spherical triangle, one angle is 90 degrees. If we do have the quadrantal, so at least one side measures 90 degrees. And if we do have isosceles spherical triangle, two sides at least two sides are equal or having the same measure. So as what you can see in this drawing or illustration of an isosceles spherical triangle. So if we do have here vertex A, okay, vertex A, vertex B, and then vertex C. Then of course, if we do have here the vertex, so this would be our angle A, angle B, and then angle C. And since we do have the vertex angle E here, so the side A is the opposite. Okay, then the opposite of angle B is this portion, and then the opposite of angle C is this portion. Okay, so by the definition, so it is said that at least two sides are equal. So in this illustration of an isosceles spherical triangle, so this is well, when the side B has an equal measure or has the same measure with side C. Okay, so here are the two sides. So side B and then side C. If that is the case, so what we are going to do, we can actually divide the isosceles spherical triangle into two. Okay, so we can divide it into two. Since the two sides B and C are the same, so we can just divide this into two, meaning that this right spherical triangle, okay, we actually formed this a right spherical triangle because we already have here the 90-degree angle, okay, on this side and also in this side, okay, in this portion, this portion. So we're able to form right spherical triangle, okay, here, also in this part, okay, right spherical triangle, because the two sides are equal. And as what you can see, so since we divided the isosceles spherical triangle into two, it will only mean that the angle A will also be divided into two. Okay, so we have here angle A over 2. So that will be the measure of this angle here. Our angle C will still be the same. And then this side, since side A, as what you can see, was splitted or divided into two also. So it would mean that for the right spherical triangle on the left, so this side would be side A divided by 2. Okay? And since we do have another right triangle on the right side, so this side will also be side A over 2, and then with the angle of well, the angle here in the upper portion, so it angle A over 2 also. So if you would notice, one side appeared, okay, one side appeared here. So this height, this altitude, this line that divides the isosceles spherical triangle into two is actually the height, the altitude that is denoted by h. Okay, so as what you can see, since there is the formation of two right spherical triangles, So how are we going to solve an isosceles spherical triangle? So what we are going to do, you're just going to consider, okay? Consider one right spherical triangle. It is up to you which one you would like to consider. Is it the one on the left or the one on the right? And then after that, you can apply the procedure, or you can do the same solution. Okay? Do the same solution um of a right spherical triangle. So that's what you can do. This is somehow the same as is you divide a triangle into two. Okay, and after that you can apply drawing the circle divided into 5 parts, and then apply the appropriate Napier's rule depending on the part that you would like to know or determine the measurement. Okay, so let us have an example. So for example, solve the isosceles spherical triangle ABC with A equals to B equals to 78 degrees and 20 minutes. So remember, in the definition of isosceles spherical triangle, so it is said, or it is described as having at least two sides that are equal. So you would notice here in our problem, so it is said that A equals to B equals to 78 degrees and 20 minutes. So what does it mean? It means that not only B measures 78 degrees and 20 minutes, but then as well as the side A, it has the same measurement. So both are 78 degrees and 20 minutes. Okay? And angle C, okay, so this is angle C. As what you can notice, this is a big C, measures 188 degrees and 50 minutes. Okay, so the first thing that you need to do here is you have to draw. Okay, draw the triangle, draw the spherical triangle. When you draw the spherical triangle, so remember what you need to do is after drawing the spherical triangle, so remember you have to divide it into two. Okay, so if you're gonna divide it into two, um just take note that if you can remember our illustration a while ago in the definition of the isosceles spherical triangle in the previous slide, so the side on the left and on the right are the ones that are equal. Okay, you have to remember that. And then just remember that the given angle is the one that you should put on the apex. When we say apex, it is on the topmost. Okay? It is the topmost portion of the spherical triangle. So it is on the tip. That is our apex. So in our given here, so the angle is C. So it means you're gonna put C on the tip. Okay? Then the two sides that are equal, so you're gonna put it on the left side and right side of your isosceles triangle because they have the same measurement. So you have your A here, then you have here your B. Then you just complete the parts. Okay. So let us switch to the black screen. Okay, so let us write here the given. So it is said in the problem, so we do have A that has an equal measure as B that measures 78 degrees and 20 minutes. And we do have angle C. It measures 118 degrees and 50 minutes. So it is said that we need to solve the triangle. Okay? So in solving the triangle, so you have to solve for the unknown parts. Um let us just start with the drawing first. Okay, so let us draw a right This is an isosceles. Okay, so let us draw the isosceles spherical triangle. So say that this is a portion of the great circle. Okay, so it will look like this. And then again, so the sides that are the same in measure, you're gonna put it on the left and the right. So it is up to you. If you would like to have your B on the left, your A on the right, well, it doesn't matter because they are the same. Next, the angle that is given in the problem, okay, the angle that is given in the problem, you just remember that it is the one that you need to put on the tip. Okay. So if this is your well, if this is your triangle, your isosceles triangle with these parts that are given, you just complete the labeling of other parts. So if we have here big C, so automatic, its opposite is small c here. If we have your side B, the angle opposite it is the angle B. If this is side A, then the angle opposite it is angle A. That's it. So this is your complete isosceles spherical triangle. If we are going to solve for it, or if we are going to determine its parts, so what we need again is to what? So we need to divide it into two. So it is the procedure in solving um, an isosceles spherical triangle. So you have to divide this into two so that you can come up with two right spherical triangles. Okay, two right spherical triangles. So as what you can see, so this is the first right spherical triangle on the left, the second is on the right. Then this will be your H. Remember? So we have the altitude. Next. So since angle C was divided into two, okay, also, so it means we do have here angle C, that is a big C, and then that is over 2. Same as with this one, so this is a big C divided by 2. When it comes to our side, okay, side opposite angle C, so that is side C. So you're also going to divide it into 2. So you have small c over 2 and then small c over 2. Okay, so we're able to complete the parts. So I saw Celeste, then having two right spherical triangles. Next, so in order to solve for this, so what you need to do is to draw. Okay, you have to draw the circle so that you can apply the Napier's rule. Because remember, we're able to come up with the right spherical triangle. So you can just use either of this. Okay, just use either of this. So circle, so you have to draw the circle. So divide it into 5 parts. And then, if you would like to use, for example, you would like to use the left side. So let us use the left side. So since on the left side, so what we have, so we have here a big B, we do have here a big C over 2, we do have here the right angle, okay, then we do have here the small c over 2, that is for the side, then we do have here side A, we do have here the H. Let us just put it inside so that it will be somehow the same as our drawing. Okay, so here is the H. That's it. So since this is a right, okay, so this is a right spherical triangle. Okay, this is the left side. Left. So this is our left. This is the right. So let us use the left. So now we're going to write the parts inside the circle. Okay, so how are we going to write the parts inside the circle? So you have to what? So as what you can see, so we do have, so what are the parts that are here? So we have the small a, okay? Then we do have the big C over 2. So big C over 2. For you not to be confused with the smalls and big C, you just put angle symbol on the big C. Okay? Then we do have the height. So as what you can see, based on the parts that we have here. So you're gonna write it this way. So from the side A going to angle C over 2 going to our H, then side C over 2 up to angle B. Okay. So H, we have small c over 2, then we do have angle B. Okay, next. So we're gonna put, remember, we always do have complement, okay, inside the circle. So where are we gonna put the complement? So we're going to put complement, well, to our angle, to the angles of the big c over 2, and also you're gonna put complement on the side A. Okay, so that is what you are going to do. Then the other two parts, the height and the splitted side. The splitted side. So you're not gonna put complement, okay? You're not gonna put complement. So you're not gonna put complement on the height as well on the splitted side. Only the two angles and the given side. Okay? Next, or the side of this right spherical triangle from the quadrantal, because it is the original side. Unlike this one, the C over 2, this is not anymore the original, because the original of the quadrantal is the side C. So we already deducted half. Okay? So after this, you can already solve. So in solving, so what you need to do is identify first. So what do we have from the given? So from the given, so remember we do have side A. So we have side A. Next, also from the given, we have a big C. So in our circle, it is the complement of angle C over 2. So what is our C over 2 here? So let us divide this first. Okay. So for C, for a big C, okay, a big C over 2. So you divide. So you divide it into 2. Okay. So that is 118 degrees and 50 minutes over 2. So you input it in your calculator. So 118 degrees. Remember, you should be in degree, minute, and, well, in degree mode rather, so that you can have the degree, minute, and second format of your answer. Okay. So it is 59 degrees and 25 minutes, 0 seconds. So just up to the minute, because the second is already 0. Okay. So we already have a value for our what? Or a measure for our angle C over 2. So what you need to do here is you start first solving for the what? You can start solving with, well, um with this one, okay? Because this one is unknown, so it is here, angle B. So you apply again the Napier's rule. So what can we apply in the Napier's rule? So Napier's rule, we can apply Napier's rule what? So you have to identify. So with this, of course, we do have the middle. And then the two parts here are adjacent. So we can apply Napier's rule number 1. Okay. So in Napier's rule number 1, so it is said that the sign of the middle, which is the complement of small a, equals So since this is adjacent, so we're going to use tangent of the complement of big B, tangent of the complement of angle C, that is complement of angle C over 2. I'll just rewrite it. I'll just erase this portion so that we can have enough space. Okay, I will erase this portion so we can have our solution here. Also this one. So let us just draw again the circle here. Make it a little bigger. Okay. So we have big B, small a, angle C over 2. Then we have here the H and then side C over 2. And then the parts, well, the angle, so we're going to put complement as well as the given side, except H and the side that we divided into 2. So we're not going to put complement. Next, so with the given, so the given side A, we also have angle C over 2, then we can solve for angle B. Then this is the middle. These two are adjacent. So let us erase this one. Okay, now let us apply the Napier's rule. So Napier's rule again, so what we're going to apply is number 1. Okay, what we're going to apply is number 1. So Napier's rule number 1, so that is sine of the middle. So our middle is the complement of side A. So we have adjacent, so we're going to use tangent. Then the two adjacent parts, so complement of angle B and the complement of half of angle C. Okay, then let us have the final equation. So for the final equation or formula, so again, we're going to use cofunctions. So if we have sine, so write it as cosine, vice versa. If we do have tangent, write it as cotangent, vice versa. So since we have the CO here, so we're going to write sine as cosine. Okay, let us copy the given side, or rather the side or part here, so which is side A. Then tangent complement, so we're gonna write tangent as cotangent of angle B. And then we also have here CO, so tangent will become cotangent also of the angle C over 2. Okay. So what we can do with this, so we can already derive the formula. So derive the formula. So we have cosine of side A. So cosine of side A equals, cotangent of B is also equal to 1 over tangent of angle B. Cotangent of angle C over 2 is also equal to what? 1 over tangent of angle C over 2. Okay. Then what do we need is angle B. So before that, so let us multiply first the right side. So 1 times 1 is 1 over tangent of angle B, tangent of angle C over 2. Okay. Next. So after this, so let us just write it on the upper portion. So after this, let us continue. So we do have already cosine of side A equals to 1 over tangent B, tangent angle C over 2. So what we need is angle B because we do not have its measure yet. So let us apply the cross multiplication because we do have one turn on the left and then on the right we do have a fraction. So we can apply cross multiplication here. So in cross multiplying, so we have cosine of side A, tangent of angle B, tangent of angle C over 2 equals to 1. Okay, again. So what we need here is angle B. So we have to divide both sides by um, cosine of A, tangent of angle C over 2. So both sides, cosine of A, tangent of angle C over 2. Next, we can already cancel. So let us cancel this. So what will be left here is tangent of angle B equals to 1 over, so we divide both sides by cosine of side A, tangent of angle C over 2. This is in this portion because of the space is small. So cosine A times tangent of angle C over 2. So it is here. Okay. Next. So since we need to derive the formula, so angle B equals, so we have to move the tangent to the other side. So we're gonna apply the inverse. So arc tangent, um, let us delete this portion. Then you just copy the right side. So we do have B equals to arc tangent 1 over cosine of side A, tangent of angle C over 2. Then after that, you can already substitute. This is already your derived formula. Okay, you can substitute already. So let us substitute. So we have B arc tangent. Then we do have 1 on the numerator, cosine. What is our side A? Side A is 78 degrees and 20 minutes. Okay. Then we're gonna 59 degrees. So we have 59 degrees and 25 minutes. Then you just close it. So you close it. Okay, so again, we have B equals to arc tangent of 1 over sine 78 degrees 20 minutes times tangent of 59 degrees 25 minutes because angle C over 2 is here. So this is what we are going to use after dividing the given angle into 2. So you can already input it in your calculator. Remember, it should be in degree mode. So arc tangent of 1 over, so cosine of 78 degrees 20 minutes times tangent of 59 degrees and 25 minutes. So you need to input it correctly in your calcu. Okay, so please have the DMS format. So the answer after inputting it in your calcu. So angle B measures 71 degrees, 6 minutes, and 40 seconds. Angle B of the isosceles spherical triangle. Okay. So next. So since we're done solving for angle B, so we already have angle B. Okay, we are done with this. Let us just put a check. Okay. So let us solve for the other part. The other part that we can solve here is this portion, the C over 2. Okay, we'll try to solve this and then we're gonna have the measurement of the small c, the side C of the isosceles. So let us clear this. Okay. So the next that we are going to solve is this from the circle. Okay, from the circle. So as what you can see, so considering the given side A angle C over 2 and the unknown C over 2, so which one here is the middle? So the small C over 2 is the middle, and then the two parts here are opposites. Okay, opposite parts. Then let us apply the Napier's rule. So which Napier's rule are we going to use? So it is Napier's rule number 2 because we do have cosine. So in Napier's rule number 2, so it is said that the sine of the middle part, so our middle part is the small c over 2 equal. So since we do have opposite, so what we're gonna use is the cosine. Okay. Then the two parts that are opposite are the complement of side A and then the complement of angle C over 2. Okay. Again, you have to put the angle so that you won't be confused which one is the small and which one is the big C. Okay, next. So let us have the final equation here. So in the final equation, kindly apply the cofunctions. So here on the left, so we do not have the CO, so we're just going to copy it. On the right, we do have CO. So cosine will become sine of the particular part, so side A. And then also another CO here, so it will become sine for the cosine. And then angle C over 2. Now, let us derive the formula. So derived formula for the unknown. So remember, our unknown is the small c over 2. In the final equation, so as what you can see, the small c over 2 is already on the left. So what we're going to do is we can just simply what? We can just simply move the sign to the other side. So I'll just rewrite it. Okay. So let us move sign to the other side, so that we can have C over 2 on the left, then on the right. So sine will become arc sine. Okay, then copy well, what's on the right side. So we have sine A times sine of angle C over 2. Okay, next. So since we're going to solve the C over 2 from the circle, so we can already substitute. Okay, let us substitute. So we do have C over 2 arc sine. So we do have here sine. So let us take a look at the given. So in the given, so side A measures 78 degrees and 20 minutes. And then angle C over 2 measures 59 degrees and 25 minutes. So input it in your calcu. So the answer in DMS is 57 degrees, 28 minutes, and 9.93 seconds. By the way, we don't round it off yet. Okay, we don't round it off yet. So 9.93 seconds. Why is it that we don't round it off yet? Because remember, what we need is to solve for the isosceles spherical triangle parts. So since the C over 2 is not yet the part of the isosceles spherical triangle because it is part of the right spherical triangle. So we have to what? What we only need is to solve for the small c. So small c is the side c of the isosceles. So what we're gonna do next, okay? So this is not yet the part of isosceles. Okay, so the next thing that we need to do is to solve for side C. So since C over 2 is 57 degrees, 28 minutes, and 9.93 seconds. Okay, so we do have C over 2 equals to 57 degrees, 28 minutes, and 9.93 seconds. So what we're going to apply here is simply cross multiplication. So what we're going to have here is C equals to 2 times 57 degrees, 28 minutes, and 9.93 seconds. So you input this in your calcu. So that is 2 times 57 degrees, 28 minutes, and 9.93 seconds. Okay, so the answer is 114 degrees, 56 minutes, and 19.86. So 19.86. Since this is already side C, okay, so seconds. This is the side C of the isosceles spherical triangle. So you just so you just write it as 114 degrees, 56 minutes, and 20 seconds. So this is the answer. So no need to solve for the H. What you only need to solve here are the big B and the small c. Possible you might ask, since we only solve for the big B and small c, how about the big A? The big A is not in the given, and we also need to solve it. By the way, class, since we divided the isosceles spherical triangle into two, so having two right spherical triangles, and remember, you can solve either of the two right spherical triangles. So whether you're gonna have the part with the big A or the part with the big B, so you're gonna have the same answer. So since our big B a while ago, so since the big B is 71 degrees, 6 minutes, and 40 seconds, and knowing that side A and side B are the same, so the angles A and B are also the same. Okay, they are the same. Then you just write here your small c. So small c is 114 degrees, 56 minutes, and 20 seconds. You can also try to solve the other triangle. You're gonna know that, or you're gonna find out that you're gonna have the same answer. So if you solve for the other triangle, what you're gonna solve there is the big A and the small c. So the big A, after computing, will still be 71 degrees, 6 minutes, and 40 seconds. Okay, so that's it for the isosceles spherical triangle.